Let us try to understand one interesting concept based on what some interesting question can be solved. The concept here I would like to tell is the decimal equivalent of maximum possible n digit base r number is r to the power n minus 1 in base 10. What it means to end is, suppose for example, if I say I have a 3 digit base 7 number. So if I say it is a base 7 number and I have 3 digit. So what is the maximum number you can generate? So base 7 is used means maximum digit that can be used is 6. So if you take all these values 666, then it is the largest number. Or if I am having a 4-bit case of, let's say, base 5. So base 5 means maximum digit can be used is 4. So if all the digits will be 4, this is the largest number. Now I'm telling you, you find the decimal equivalent of these numbers. So how to get the decimal equivalent of a number? So it is simply you are converting any base to decimal. So how do you do it? By doing the polynomial expansion. If you find its polynomial expansion, so you get 6 into 7 square plus 6 into 7 power 1 plus 6 into 7 power 0. Similarly, in this case, if you find it out, so this will be how much? 4 into 5 power 0, 1, 2, 3 plus 4 into 5 square plus 4 into 5 power 1 plus 4 into 5 power 0. Take a calci and you simplify this, students. How much this will be? Let us see. So, like if you find it out, so 7 square is 49. So 49 into 6 is 294. This is 294 plus 42 plus it is 6. So if you find it out, so this is coming as 342. So my claim is this 342 can be written as 7 to the power 3 minus 1. So from where this 7 is coming? This 7 is coming from the base. From where this 3 is coming? The 3 is number of digits. So this is number is equivalent to radix to the power number of digit minus 1. That is what I have written. The decimal equivalent of maximum possible n digit base r number. This is the maximum possible n digit base 7 number is r to the power n minus 1. So this is equivalent to r to the power n minus 1, where r value is 7 and n value is 3. Similarly, if you do with a calci, so this will be equivalent to 5 to the power 4 minus 1, because r is 5, number of digit is 4, so 5 to the power 4 minus 1. This is the answer. Similarly, if you take a 4-digit base 6 number, so you can see this is 6 to the power 4, 6 to the power 4 minus 1. So r to the power minus, always this pattern will always follow. Please keep this in mind, and keeping this in mind, so let us try to solve these two interesting questions. Let me see how many of you can answer this. You pause the video and try to simplify this problem and then match the answer with the video what I'm going to tell you now. The question is, how many minimum bits are required to represent largest 26-digit decimal number of binary? So see the term largest 26-digit decimal number. So you want to represent the largest 26-digit decimal number in binary number system. So how many minimum bits you need? How many minimum bits you need? So first thing is, what is the decimal equivalent of largest 26-digit decimal number? Using the formula, that number would be r to the power n minus 1. So that number in this case will be 10 is the radix, because decimal means base is 10, and 26 digit, that means n value is 26. 10 power 26 minus 1. So you want to represent this number 10 to the power 26 minus 1 using binary bits. So how many binary bits are needed? So I don't know how many bits are needed. So let's say in the in this base 2, so how many bits will be required, I don't know. So let's say I need, let's say, k bits. So if you are using k bits, using k bits, what is the maximum number you can represent in the decimal formats? In base 2 number system, if you are using k bits, so to represent this, I am assuming I need k bits. So if you are using k bits, so what is that number that can be represented in binary number system if you are using k bits? So again, you go for the maximum possibility. So this will be 2 to the power k minus 1. So from this equation, you have to solve the value of k. So this implies, if I am simplifying this, 1 and 1 cancel because this number are in decimal format. So this is in decimal format and even this is also in decimal format. So what this is telling? This is telling the largest number that can be represented using k bits in base 2 number system. Right? And this is what I am equating it to 10 to the power 26 because I have to reach to this quantity. What is that value of k I should take so that this will be equals to this? So that means 2 power k is equals to 10 to the power 26. 10 to the power 26. So how do you get the value of k? Take log base 2. Log base 2, 2 power k is equals to log base 2 10 power 26. So this implies k equals to 26 log base 2 10. 26 log base 2 10. If you simplify this, students, by taking a calci, so this is coming as 86.37. So the value of k is coming as 86.37. So you cannot take any fractional part 86.37. So you have to take 87. So the k value is 87. I should take it is 87. So if you take 87 bits, so you can represent this. So in other words, 2 to the power 87 minus 1. So this number will be equivalent to 10 power 26 is what I want to claim. I hope you understood this logic. So can you see the next question, students? Can you see the next question? So if you see the next question, what is given is, so how many minimum bits are required, how many base 4 digits are required to represent largest 10 digit base 7 number? How many base 4 digits are required to represent largest 10 digit base 7 number? So if you understood these questions, so this question directly you can answer. So what is the equation we are writing? So 10 largest 10 digit base 7 number. What is the meaning of it? So the meaning of this will be r to the power n minus 1. So r is 7. 7, n is 10. 7 power 10 minus 1. This should be equals to how much? How much? So it should be equals to 4 to the power k minus 1. Because base 4 you are using. So 4, and again if I am using k number of bits. So 4 power k minus 1. So this implies 4 power k is equals to 7 power 10. So k is equals to log base 4 7 power 10. So this implies k is equals to 10 log base 4 and this is 7. Take a calcium and simplify this. That will be your corresponding answer. Okay, na? So this is one of the best problem in number systems. So if to answer this, you should have this idea, and even if you do this idea, so you should get the idea to generate this equation, to generate this kind of equation. And then little bit of maths knowledge with respect to log. Okay. And this is one concept, and one more concept I want to attach here, that is you see. So let me show here. Let us see. Suppose for example, I have a number, students, let's say 6, 7 in base 8. Now what I am saying is, you find the decimal equivalent of it. So decimal equivalent of it will be 8 into 8 power 1 into 6 plus 8 power 0 into 7. So this is 48 plus 7 is 55. Now what you do is, you attach a 0 on the LSB. So 6, 7, 0 and 8. Now again you find the decimal equivalent. So you get 8 square into 6 plus 8 into 7 plus 0. So 8 square is 64. So how much is 64 into 6, students? 64 into 6 will be 384 plus this is 56. So how much this is coming? So this is coming as how much? 384 plus 56. This is coming 440. 440, right? So this 440, this is equivalent to 55 into 8. This is equivalent to 55 into 8. The point I want to tell is, in any base number system, if you have certain number, if you attach a 0 on the LSB, so the value of number increase by base times. Like here, if I'm attaching a 0, so then if you find the decimal equivalent, so that will be base times 8 times this one number. So 8 into 55. In other words, what I'm saying is, now if I'm attaching one more 0, 670 is there, again I'm giving one more 0. If I ask you what is the decimal equivalent of this, so this will be again 8 times of this. So 55 into 8 into 8. So this is true in any base. For example, you take a base 4 number. In a base 4 number, let's say you have taken 33. So what is the decimal equivalent of this 33 in base 4? This is 15. 4 into 3 plus 3. So you are getting 15. My claim is, if I say it is 330 in base 4, so my claim is, so this will be 4 into 15. You can check it out. It will come or not. So you see, that is 4 square into 3 plus 4 into 3 plus 0. 4 square is 16. 16 into 3 is 48 plus 12. So you see this is coming 60, which is 4 into 15. You put one more 0. So this will be multiplied by 4. You put one more 0, it will be again multiplied by 4. So the point is, it doesn't matter what base I have. If I have an existing number, in that number, if I am keep on adding 0 on the LSB sides, then each time on addition of each 0, the value of number will increase by base times. I'm speaking about the decimal equivalents. Okay. So how can I write this? If decimal equivalent of, let's say, a number A3, A2, A1, A0 in base R is n. Okay. So the decimal equivalent of a base R number is n. Then decimal equivalent of A3, A2, A1, A0, then 0, 0, 0, k number of 0. That means total I have k number of 0. So what will be its decimal equivalent? So this will be R to the power k. R to the power k into n. R to the power k into n. So original number is n, then addition of each 0 will multiply R. So if I'm having only one 0, so if I'm asking what is the decimal equivalent of only this much, so it is n into R. So if I ask you up to this much, so it will be again one more R time it will multiply. So n into R square. If I'm taking 3 0, it is n into R cube. So if you have k number of 0, so n into R power k. So this is the concept. So using this, let us try to understand, or let us try to solve this beautiful problem. If decimal equivalent of A4, A3, A2, A1, A0 in base 6 is n, then what is the decimal equivalent of A4, A3, A2, A1, A0, 534 in base 6 in terms of n? So I have a base 6 number, its decimal equivalent is n, right? So what is the data given is A4, A3, A2, A1, A0. Okay. So this is in base 6, its decimal equivalent is n. Now students, this number which is A4, A3, A2, A1, A0, 534. So this can be written as A4, A3, A2, A1, A0, 0, 0, 0 plus 534. Do you agree or not? So this can be written as sum of this and this. So this is in base 6 and even this is in base 6. And if you are adding 0 with any number, you get the same number in any base. So if you are adding 0 with any base, you get the same number. So 5 plus 0 will be 5, 3 plus 0 will be 3, 4, and these all are zeros. Okay. Now, what is the answer is? The answer will be decimal equivalent of this plus decimal equivalent of this. So what is the decimal equivalent of this one? So you see that here I have given here 3 number of 0, additionally 3 number of 0. So this will be increased by, so this value is n, right? So this value is n. So it will be 6 power 3 into n. 6 power 3 into n. I mean this entire thing. So this entire thing is because three zeros I have given. So here, you know, like using this formula, r to the power k into n. So if I am giving 3 0, so r is 6. So 6 power 3 into n. So this should be added with the decimal equivalent of this number. So what is the decimal equivalent of 534 in base 6? So it is 6 square into 5 plus 6 into 3 plus 6 power 0 into 4. So this is 36 into 5. So what is 36 into 5? So 36 into 5 will be 180. 180 plus 18 plus 4. So this is 180 plus 22 is coming 202. So this is this things plus 202. Are you getting or not? So this is equivalent to 6 power 3 into n, and this is equivalent to 202. Now you can add it. I mean, the decimal equivalent of this is this much, decimal equivalent of this is this much. So now this is in decimal form, this is in decimal form, you can add it. So that is, what is the answer of this one? What is the decimal equivalent of this number is 6 power 3 into n plus 202. So what is 6 power 3? So 6 power 3 is 36 into 6, which is 216. So 216n plus 202. This is the answer. So don't you think it's a beautiful question? Yes, it needs brain. So first of all, you should have this idea, and once you have this idea, then you should have idea to write this number as summation of these two, and then rest of the things is normal maths. So answer is 216n plus 202. So this is what, friends, all about the number system concept. Hope you enjoyed the videos. Thank you.